Alright, so I think this is recording. Let's take a look at solving some of these trig equations. For this equation, we have infinitely many solutions. However, they're only wanting us to state the solutions that are between 0 and 2 pi. So we have one trig function, sine, and so we isolate it by adding 1 to each side. The inverse sine of 1, we don't need to use a calculator because this is one of the known values of our special right triangles. It's on a unit circle. When the y-coordinate is 1, this angle 3x will be at pi over 2. So let's solve this for x by multiplying each side by 1/3. And we have a solution that is pi over 6. Now pi over 6 is bigger than 0 and it's less than 2 pi. So that is one of the solutions to this equation. But there's more, and we need to go back and recognize that the coefficient in front of x is 3, and that's going to be actually a horizontal shrink, and by shrinking horizontally, that's going to introduce more solutions on this interval from 0 to 2 pi than what we would just have if that were a 1. So remember, to find the period, you take 2 pi divided by the coefficient divided by 3, and that's this new period. Well, so for this pi over 6, if I add, go to the next cycle, I have 2 pi over 3, and then I can do that an integer multiple number of times. Now, oftentimes you'll have students that say, well, I was expecting another answer. See, this pi over 2 isn't falling in a quadrant, it's falling on an axis. So that this is the only equation that we need to deal with and solve it in finding all of the solutions between 0 and 2 pi. So if we come over and make a table real quick, well, I don't know how quick, but if n is 0, we've already said that pi over 6 is a solution. Now, since we have a denominator of 6, let's go ahead and rewrite 2 pi over 3 so that it has a denominator of 6, just to make it easy for us to add these fractions together. So when this is 1, we've got 1 plus 4, so we've got 5 pi over 6. And remember that 0 to 2 pi, let's rewrite that 2 pi with the denominator of 6. Let's write this 2 pi as 12 pi over 6 so that we know when to stop. That numerator is 12, and right now we're at 5, so we're underneath, we're less than that 12. So when n is 2, this is 2 times 4 is 8, 8 plus 1 is 9, and 9 is less than 12, so I continue in my list of solutions. When n is 3, 4 times 3 is 12, 12 plus 1 is 13. That's bigger than 12. So I'm not going to include this 13 pi over 6 in my solution. So my solution set has 3 values in it: pi over 6, 5 pi over 6, and 9 pi over 6. We can reduce 9 pi over 6 to 3 pi over 2. We can actually use our calculator to check and see if these solutions are valid. I'll just check that last one. You can check the others if you'd like. Now, if I'm going to check it on my calculator, I need to make sure that I'm in radians, and it wanted exact answers. Well, I'm not using the calculator to give answers. I'm just using my calculator to check my answers. So it was 3 times what we found x to be. So in this case, we've got 3 pi over 2 for this one if I'm checking it. And I need to close the parenthesis and then subtract 1. And I'm expecting 0. And I got that. And I could replace the 3 pi over 2 with these other, with pi over 6 and 5 pi over 6, and it should check as well. So here is our final solution. Alright, so let's do another one on this video. Here's Here's one. We just have a single trig function, tangent, so when I look on the left-hand side, I have two terms. The first term has the variable of interest x, so I want to get that term by itself. So I subtract the square root of 3 from each side. Alright, so now I look at this left-hand side and I have two factors. And it's the second factor that has my variable of interest. So the inverse of multiplication is division. So I'm going to divide both sides by 3. And 3 divided by 3 is 1, so those common factors cancel. I now take the inverse tangent of each side. And this negative radical 3 over 3 is a ratio y to x that's on my unit circle. I don't need the calculator to find this. So this angle x plus pi over 2 would be equal, well, for when tangent is negative, you're going to look either in quadrant 2 or quadrant 3. If you look in quadrant 2, and you look at, let's see, let me think, 5 pi over 6. Yeah, alright, I believe I should pull up a unit circle and check. You know, I'm going to pause this and pull up a unit circle and double check, because I don't want to make a mistake on these videos. But I believe that at 5 pi over 6, if you take the y coordinate divided by the x coordinate, that you'll get, you know, negative 1 over radical 3, which rationalizes to negative radical 3 over 3. But let me pause this and go grab a unit circle. Alright, so I'm back, and you can see that I've pasted the unit circle here, and I was correct that at 5 pi over 6, if you take the y coordinate divided by the x coordinate, you'll get negative 1 over radical 3, and that rationalizes to negative radical 3 over 3. Alright, so let's solve this for x. If we subtract pi over 2, we want to write pi over 2 with the denominator of 6. So we'll rewrite pi over 2 as 3 pi over 6. And we have a solution that reduces to pi over 3. If we look back at the original equation, coefficient in front of x is 1. If we were writing infinitely many solutions, it would just be plus n pi. Let's rewrite the pi as 3 pi over 3 times n, and that will help us find all of the solutions that are between 0 and 2 pi. When n is 0, when n is 0, then we have a solution at pi over 3. When n is 1, we have a solution at 4 pi over 3. Because remember, the period for tangent is pi, not 2 pi like the other 4 trig functions. When n is 2, we have 7 pi over 3, and that's too big, because if we rewrite our 2 pi as 6 pi divided by 3, we can see that 7 is bigger than 6, and that's too big. So the two solutions, there's infinitely many solutions to this equation, but the two that are between 0 and 2 pi are pi over 3 and 4 pi over 3. And let's check that real quick. Illustrate again that we can check our answers on the calculator. They're wanting exact values, but we can look at the decimal number and oops, I forgot to put there's a 3 there. 3 times the tangent of our solution. Let's check 4 pi over 3. And then it's plus pi over 2. Close that parenthesis, and then add the square root of 3. And we expect 0 or something ridiculously close to 0. and we got 0. So it checks, and there's our solution for that. So I'm going to stop this video and do others on separate videos. So I hope that helps, and I'll talk to you later.